Hello everyone. In the beginning of the class, let us see new announcements. Okay. The first new announcement is May 5th, 2022. Class videos uploaded. Hello everyone. I have uploaded class videos of May 5th, 2022 to YouTube. Their URLs are this, and this. Best regards, Wei Zhen. Okay, the next new announcement is the handout of Chapter 2 has been updated, version 2022-0510. Hello everyone, I have uploaded the latest version of the handout of Chapter 2 to eCourse 2 website. The location and the file name are eCourse 2 website, wireless communications and machine learning, course content, handouts, Chapter 2 handout 2022-0510.pdf. Best regards, Wei Zhen. Okay. Next, let us look at the progress of the last class. Okay, in the last class, we have taught to Chapter 2 handout, problems, page 47, problem 31, solution unfinished. Okay, please open the handout of Chapter 2. Okay, and search for page 47. Okay, and search for problem 31. Okay. Okay, let us see problem 31. What is a metric space? Okay, why do we need to know what is a metric space? Okay, because it appears here. Okay, in the solution to problem 30, what is topological interior? Okay. Then why do we need to learn what is topological interior? Okay, let us go to topology. Okay, topological interior. Okay, because it appears in the solution to problem 29. What is neighborhood topology? Okay, then why do we need to know what is neighborhood topology? Okay, let us search for it. Okay, because it appears in solution to problem 26. What is a topological space? And why do we need to know what is a topological space? Okay, because it appears in the solution to problem 25. What is a topological field? Okay, then why do we need to know what is a topological field? Okay, because it appears in the solution to problem 24. What is a topological vector space? Okay, and then why do we need to know what is a topological vector space? Okay, let us search it. Okay, copy. Okay, because the topological vector space, abbreviated as TVS, appears in the solution to problem 13. What is a locally convex space? Okay, then why do we need to know what is a locally convex space? Okay, let us copy it and search for it. Okay, because the locally convex space appears in the solution to problem 4. What is a subgradient? Okay, then why do we need to know what is a subgradient? Because subgradient appears in the solution to problem 3. What is subdifferentiable? Okay, then why do we need to know what is subdifferentiable? Okay, let us search for it. Okay, because subdifferentiable appears in problem 2. What is stochastic? A stochastic gradient descent. Okay, then why do we need to know what is stochastic gradient descent? Okay, it is because it appears in the slides of chapter 2. Okay, and search for the stochastic. Okay, because it appears on page 47 of the slides of chapter 2. Okay, stochastic gradient descent. Okay, let us go to problem 31. Okay. Okay, problem 31. What is a matrix space? Solution, definition. A matrix space is an ordered pair MD where M is a set and D is a metric. Okay, we will explain what is metric later. On M, that is a function. Okay, D is the name of the function, and M times M is the domain of the function, and R is the range of the function. Okay, where the times means the Cartesian product, okay, which we have introduced earlier. And R is the set which contains all real numbers. Okay, next page. Okay, such that for any x, y, z in M, the following holds. Okay. First, d of x, y is equal to 0 if and only if x is equal to y. Okay. It is called the identity of indiscernibles. Okay, second, d of xy is equal to d of yx. It is called the symmetry. Okay, third, d of xz is smaller than or equal to d of xy plus d of yz. Okay, it is called the subadditivity or triangle inequality. Okay, why is it why does it be called why is it called the triangle inequality? Okay, let me draw a figure on the blackboard. Okay, because I do not have a blackboard with me now, so I use the Microsoft instead. Okay, first let me draw a triangle. Okay, like this. Okay, and turn it to, oh, okay, sorry, I need to draw it again. Okay, first let me draw a triangle. Okay, like this. Oh, good. Okay, then let me, okay. So let me name the three vertices. Okay, so this is, okay. This is X. Okay. So I need to no fill in and no friend. Okay, like this. So it is X. Okay, then this vertex is called Y. Okay. Okay, and this vertex is called Z. Okay, like this. Okay, and the length of this side we called it the d of xy. Okay. D of xy. Okay. Okay. D of xy. Oh, sorry. Okay, like this. D of xy. Okay. And the length of this side we call it d of yz. Okay, d of y z. Excuse me. And the length of this side we call it d of xz. Okay, like this. And let us see this equation d of xz. Okay. Oh. Okay, d of xz is smaller than or equal to d of xy plus d of yz. Okay. Okay, like this. Okay. So we can see that d of xy, d of xz is the length of this side. Okay. And d of xy is the length of this side. And d of yz is the length of this side. Okay. Of course, in a triangle, the sum of the length of any two sides. Okay. For example, this side and this side, okay, is greater than the length of the third side, that is d of xz. Okay, so when will the equality holds? Okay, when will the equality hold? Okay, the equality hold when y is on the line segment xz. Okay, then we can see that I think I need to draw another graph. Okay. Okay, like this. Oh, I need it to convert to a line. Okay, let me draw it again. Convert to a line. Okay, so let us call this, okay, x. Okay, this point as x and this point as z. And okay, another point. Okay, let me draw another point. Okay, for example, the point here. Okay, so this point we call it y. Okay. Okay, so in this figure we can see that the point y is on the line segment xz. Okay, so now this inequality becomes, how can I insert equation here? Okay, so, oh, sorry. So let me see. Okay, x, y, z. Okay, and I combine them as a group. Okay, and then I set 围绕图上及下. Okay, good. Okay, similarly, I take this as a group. Okay. Okay, and combine them as a group. Okay, and I again 围绕图上及下. Okay, good. Okay, so now this this inequality, okay, here becomes okay. Okay, how can I insert equation here? Oh, it's not easy to use. Okay, okay, here. Okay, then I insert a text box. Okay, here. Okay, and insert or copy the equation here. Okay, so in this figure, we can see that dxc, okay, it is the length of this segment. It is equal to, okay, d of xy, okay, it is the length of this segment, plus d of yz, okay, it is the length of this segment. So we know that the equality of the triangle inequality holds when x, y, z are on the same line. Okay, good. Okay, so let us go back to the handout. Okay, given the above three axioms, okay, 1, 2, 3, okay, there are three axioms. We also have that d of xy, which is greater than or equal to 0 for any xy in N. This is deduced as follows, okay, or we can say this is derived as follows from the top to the bottom. Okay. So first, okay, d of xy plus d of yx is greater than or equal to d of xx. Okay. This is simple because you can replace z here by x. Okay, then this z will be replaced by x2. Okay, so this is by the triangle inequality. Okay, here triangle inequality. Okay, then we know that d of yx is equal to d of xy. Okay, this is by symmetry. Okay, because in the second axiom, d of xy is equal to d of yx. It is called the symmetry. Okay, then d of xy plus d of xy, because these two, because they are both real numbers, so we can write 2 times d of xy, which is greater than or equal to 0. Okay, because d of xx is greater than 0. Oh, sorry, d of xx is equal to 0. Okay, it is by identity of discernibles. Okay, here d of xy is equal to 0 if and only if x is equal to y. It is called the identity of indiscernibles. Okay, finally we divide this inequality by 2 on both sides. Okay, then we can have d of xy is greater than or equal to 0. Okay, then we have non-negativity. Okay, so the function d is also called distance function. Okay, so this is why we use the letter d, okay, as the name of the function, or simply distance. Okay, often d is omitted and one just writes M for a metric space if it is clear from the context what metric is used. Okay, ignoring mathematical details, for any system of rows and terrains, the distance between two locations can be defined as the length of the shortest route, okay, or route connecting those locations. Okay, for example, if I had a place, okay, if I have a place A, okay, and have a place, oh, good, then I can copy it. Okay, for example, if I have a place A, okay, let me call this A. Okay, A. Okay. So let me name it as okay, change to equality. And no field, no friend. Okay, good. So this is A. Okay, and I call this place B. Okay, B like this. Okay, then we can see that the distance between two locations can be defined as the length of the shortest route connecting these locations. Okay, for example, okay, I use a line to connect these two, okay, places. Okay, like this. Okay, so this is the distance between A and B. Okay, so I can write okay this as okay d of okay d of A and B. Okay, Okay, good, like this. So let us, okay, it is 25 minutes. Let us take a break.